Welcome to the AI for Career Success video overview by Curt Robbins. We're experts at AI coaching and helping professionals like you and your employees upskill in AI. Today's analysis is grounded in the article, Immersion Cooling to Offset Data Centers' Massive Power Demands Gains a Big Booster in Microsoft, which was written by Jonathan Schieber for TechCrunch on April 8, 2021. So let's begin by examining a really fundamental conflict that's happening at the heart of modern technology. You see, the incredible growth in computing power, especially for AI, is creating a massive physical side effect, and that's heat. It's a problem that our traditional cooling methods are simply, well, no longer equipped to handle. The core of the issue is this. Our digital ambitions are running headfirst into the physical laws of thermodynamics. For every major leap we make in AI capabilities, we're generating an amount of heat that pushes our existing data center infrastructure to its absolute limit. And this isn't just some engineering puzzle. It's becoming a genuine bottleneck for future innovation. This brings us to the most critical question facing the entire tech industry right now. It's not just about making chips faster anymore. The central challenge has really shifted to thermal management. How can we possibly build a sustainable digital future if we can't effectively cool the very engines that are supposed to power it? Now, to put this problem into perspective, the data from Jonathan Schieber's reporting is pretty revealing. A legacy CPU might draw something like 150 watts. But today's high-performance GPUs, which are the real workhorses of AI, can consume over 700 watts. That's almost a five-fold increase in power, which means there's a corresponding explosion in heat coming from just a single component. And that's multiplied thousands of times over in a data center. This statement from Microsoft's Christian Belady isn't just an observation. It's really an admission from an industry leader that a critical threshold has been crossed. The era of just relying on massive air conditioners to cool high-density computing is, for all intents and purposes, over. A fundamentally new approach is no longer just an option, it's a necessity. So, in response to this crisis, Microsoft is pioneering a solution that honestly sounds like something straight out of science fiction. We're going to explore the technology at the very core of Schieber's article, two-phase immersion cooling. It's a radical departure from fans and vents, and it really could redefine data center design as we know it. So, what exactly is it? Well, to put it simply, it's the practice of submerging entire server racks directly into a specially engineered, non-conductive liquid. Now, the two-phase part is key here. The liquid absorbs heat from the servers until it boils and turns into a gas. Then, that gas is cooled, which makes it condense back into a liquid. This process creates an incredibly efficient, self-contained, and continuous cooling loop, right at the source of the heat. Let's just walk through the cycle. First, the servers are lowered right into this bath of fluid. As the processors work hard, their heat is transferred directly to the fluid, causing it to boil at a surprisingly low 50 degrees Celsius. This boiling action carries the heat away in the form of vapor. That vapor then rises, hits a cooled condenser coil in the lid of the tank, and just like that, it turns back into liquid, raining back down into the bath to start the whole process over again. It's a very elegant, closed-loop system that's driven by pure physics. Okay, let's shift gears from the mechanics to the metrics. Because for any IT professional or business leader, the true test of a new technology is its quantifiable impact. What does it do for performance, cost, and sustainability? And the numbers we're seeing here are quite compelling. In their production environment, Microsoft is reporting a power reduction of 5 to 15% per server. Now, that's a significant saving at cloud scale. What's also interesting is that Schieber notes that other companies in this immersion cooling space are claiming savings of up to 50%. This suggests that as the technology matures, the potential for even greater energy efficiency across the industry is substantial. Beyond power savings, the impact on water usage is frankly profound. Traditional data centers are notoriously thirsty, using incredible amounts of water for evaporative cooling. This new closed-loop liquid system virtually eliminates that dependency. Some systems are reporting a 99% reduction in water consumption. For any organization with serious sustainability goals, that is an absolute game-changing statistic. And the operational advantages are just as critical. Microsoft's Marcus Fontoura points out the ability to handle sudden bursty workloads, which ensures reliability when demand spikes. It also allows them to pack much more powerful hardware into a smaller footprint, which is like applying Moore's law not just to the chip but to the entire data center rack. And being the first major cloud provider to deploy this in a live production environment, well, that gives them a pretty significant first-mover advantage. Now, to fully appreciate the significance of this innovation, we really need to place it in the broader context of Microsoft's strategic thinking. This isn't just some one-off project. It fits into a larger vision for next-generation sustainable computing infrastructure. You see, Microsoft has been exploring liquid cooling on two parallel fronts. You might have already heard of Project Natick. That was their ambitious experiment to send entire data centers to the ocean floor to be passively cooled by seawater. You can think of this new immersion cooling project as the onshore counterpart. It's a way to achieve the same thermal efficiencies of liquid, but within the walls of a traditional data center. This insight from Hussam Alisa, a principal hardware engineer at Microsoft, just perfectly encapsulates the strategy. It's a brilliant, pragmatic, and scalable approach. Instead of moving the entire infrastructure to a naturally cool environment, they've simply engineered a way to replicate that environment inside a compact tank, making advanced liquid cooling accessible just about anywhere. Thank you for watching. This is where we teach you AI and help you get smarter than your competition. If you like these videos, use the QR code at the beginning of this video to buy us a coffee or hire us to coach you or your employees in AI. We also recommend you subscribe to the AI for Career Success YouTube channel. Please also like, comment, and share this content. It really helps us reach a wider audience of professionals who are all looking to advance their knowledge.